Guys, welcome to another video. In this question, they have given that a 3-meter high vertical earth retaining wall, just will draw 3 meter. The height of this retaining wall will be 3 meter, which retains a dry granular backfill at an angle 30 degree and unit weight of 20 kilonewton per meter cube. So we'll draw 20 kilonewton per meter cube and angle of internal friction will be 30 degree. Okay. They have asked us to find out the total horizontal thrust of the wall when there is no movement. So if you draw the pressure distribution diagram, it will be just like this, where the active earth pressure at the top is 0 and the bottom earth pressure will be K naught gamma H. So the value of K naught will be 1 minus sine pi, which is 1 minus sine 30. It's nothing but K naught is nothing but 0.5. So to find out the total horizontal thrust, we have to calculate the area of this triangular portion, which is nothing but half into total active earth, total horizontal thrust, half into base, which is K naught gamma H, into height, that is 3 meter. So 1 by 2 into 0.5 into 20 into H will be nothing but 3 meters into 3, which gives 45 kilonewton per meter. For this question, if you draw the diagram, it will be very understandable. They have given that the retaining wall of height h, so retaining wall of height h is supporting a cohesionless backfill which is inclined at an angle beta with the horizontal. So this must be the cohesionless backfill, and the angle of internal friction of this cohesionless backfill will be pi dash. So if you draw the stress distribution diagram, it will be something like this, where the pressure acting at the top will be 0 and pressure acting at the bottom will be nothing but Ka gamma H. So the active earth pressure will be acting at the centroid of this pressure distribution, which is centroid of this triangle. So the centroid of this triangle will be H by 3 from the base and 2H by 3 from the top. Okay, so this one is the centroid. So active earth pressure will act at a height of h by 3 from the base and at an angle beta with the horizontal, because pi dash is angle of internal friction, but the angle of cohesionless backfill, which is nothing but beta. So option C is the right answer. So in this question, they have given that a vertical retaining wall of height 5 meter. So vertical retaining wall of height 5 meter has to support a soil having unit weight. So it is supporting a soil where the unit weight of soil is 18 kilonewton per meter cube, and it is having an effective cohesion of 12 kilonewton per meter square. Sorry, 12 kilonewton per meter square. It's not meter cube, it is meter square. And effective angle of friction, that is pi dash, will be equal to 30 degrees. So they have asked that the lateral active thrust on the wall per meter length after the tension crack has occurred. They have asked us to find out the lateral active thrust on the wall per meter length after tension crack has occurred. So if you see the pressure distribution diagram of this retaining wall, it will be something like this. where this one will be your ZC, and if you extend towards this, it will be your ZC. ZC will be nothing but 2C by root Ka. 2C by gamma root Ka. And your pressure distribution at top will be 2C root Ka. Here it is compression zone, and this one is the tension zone, where the pressure distribution at the bottom will be Ka gamma H minus 2C root Ka. So if you calculate the value of Ka, it will be nothing but 1 minus sine pi divided by 1 plus sine pi. Just 1 minus sine 30 divided by 1 plus sine 30, which is 0.5 divided by 1.5. This gives 1 by 3. Okay, so they have asked this the lateral active thrust on the wall per meter length after tension crack has developed. So you have to consider this portion. You have to consider this portion. So the total height of the wall will be 5 meter, and if you neglect this part, so where it will be 2C, that is 2 into C, which is nothing but 12 divided by gamma 18 root 1 by 3. We get 2.309, which is you can take like this, and 5 minus 2.309 will be nothing but 2.691 will be this height. So the base will be, we have to calculate the value of base. So Ka gamma H minus 2C root Ka will be nothing but Ka gamma H, Ka 1 by 3 into gamma 18 into H. H is nothing but 5 meters. That is full height of the soil minus 2C. C is nothing but 12. 2C root Ka root 1 by 3. Right. In this, we'll be getting this one as 16.144 kilonewton per meter square. So the value of the base will be 16.144. So the value of active earth pressure, which is nothing but area of the pressure distribution diagram, half into base, which is nothing but 16.144 into height. Height is nothing but 2.691, which will be given by 21.714 kilonewton per meter. In this question, they have given a 5-meter high vertical wall with the saturated clay backfill. They have also given the parameters of the clay backfill, which the unit weight as 18 kilonewton per meter cube and cohesion as 20 kilopascal, and they have also mentioned the angle of internal friction of clay as 0. So what they are asking, to prevent the development of tension zone. So in the backfill, the backfill will create an active earth pressure on the retaining wall, which in turn it creates the tension zone. So what they are saying, to prevent the tension zone, how much height of the wall can be increased? To prevent the tension zone, how much height of the retaining wall can be increased, where the additional height of the wall will be cooperated by sand backfill. So the backfill will be sand. Okay. So they have given the parameters of the sand also, which is unit weight as 16 kilonewton per meter cube and angle of internal friction as 30. So also they are saying the back of the wall is smooth and top of the backfill is horizontal. Okay. So we need to find out the minimum height by which the wall can be increased to prevent the development of tension zone. Let us draw the diagram. Let us draw the diagram. consider this as the retaining wall and keep this as the backfill, where the saturated unit weight of the backfill will be, because since it is clay, we have the saturated unit weight, okay, 18 kilonewton per meter cube, and the cohesion, that is 20 kilopascal, which is nothing but 20 kilonewton per meter square, right? So the angle of internal friction they have given us 0, right? What they're asking, we have to extend the height of this wall. So we don't know the height of this wall, extension height of this wall, okay, right? So due to this active pressure, we can take this active pressure on the wall, just nothing but we can take this as surcharge, because due to sand load will get acted. So this one we take the surcharge due to sand, which is nothing but Q, which is equal to gamma B into X, where gamma B is nothing but bulk unit weight of sand, which is nothing but 16 kilonewton per meter cube. 16 kilonewton per meter cube. And this one is the height X. So we need to find out the height X, right? Okay. So from the pressure distribution diagram, so if you see the pressure distribution diagram of retaining wall, it will be something like this, right? It will be something like this, right? And this one will be your 2C root KA. This one will be your ZC. The active earth pressure at the top will be nothing but PA will be equal to 2C, sorry, Ka gamma H minus 2C root Ka. See, at this point, active earth pressure is 0. So this is the tension zone, right? This one is the tension zone. So at this point, active earth pressure is 0. They have also asked to prevent the development of tension zone. So to prevent the development of tension zone, we need to consider active earth pressure as 0. So we will put active earth pressure as 0. Then we will get Ka gamma H minus 2C root Ka. Gamma H is nothing but Q, right? Gamma H is nothing but Q. So KAQ will be 2C root Ka, where the value of Q will be nothing but 2C by root Ka, right? So we will calculate the value of Q on clay, right? So the value of Q on clay will be nothing but 2 into C. The value of C in clay is 20 by root of Ka. Root of Ka, they have given the angle of internal friction as 0. So Ka will be 1 minus sine 0 divided by 1 plus sine 0, which is nothing but 1. So the value of Q will be 40 kilonewton per meter square, right? Okay. So to accommodate this 40 kilonewton per meter square, what will be the height of wall to be increased, right? To accommodate this 40 kilonewton per meter square, how much the height of wall should be increased? So we know that Q is equal to gamma B X, which is nothing but right now we have derived 40 kilonewton per meter square, because on the top they have used sand as the backfill. Okay, so from this we get the bulk unit weight of sand is 16. 16x is equal to 40, which gives x will be equal to 40 by 16, which is nothing but 2.5 meters. So we have to increase 2.5 meters of the retaining wall to prevent the development of the tension zone. Here we can write 2.5 meters. In this question, they have given the parameters of the soil and they have asked us to find out the maximum depth of unsupported excavation. If you draw the pressure diagram, so this one is the pressure distribution diagram. If you see this pressure distribution diagram, the pressure here will be 2C root Ka, and the active pressure at the bottom of the wall will be Ka gamma H minus 2C root Ka. Here it is also 2C root Ka. So this one will be the critical depth ZC, and this one is also critical depth ZC. And this total depth, which is known as the maximum depth of unsupported excavation. Okay. So the value of ZC is nothing but 2C by gamma root Ka. So from this, H will be equal to 2ZC, which is nothing but 4C by gamma root Ka. Right. So they have given the value of cohesion, they have given the value of unit weight, and they have given the angle of internal friction. So with angle of internal friction, we can find out the value of Ka, which is nothing but 1 minus sine 20 divided by 1 plus sine 20, where you will get 0.49. So from this we can calculate the value of maximum depth of unsupported excavation. H will be equal to 4 into 15 divided by gamma, which is nothing but 17.5 into root Ka, 0.49, which gives you 4.89 meter. 4.89 meter.